Everyone, welcome to questions on electrophilic addition in alkenes. So we have this first question here, and it's asking us to suggest how an HBr molecule can act as an electrophile. So now if you know what an electrophile is, then it doesn't matter the fact it's asked you about the HBr molecule. Essentially it's asking for a definition. What is an electrophile, essentially? But how does it act as an electrophile? Well, very simply, be able to accept a pair of electrons. So it likes those electron-rich centers where it can accept a pair of electrons. So hopefully starting things off nice and easy. Now following on from this, we're then asked, we have compound D. If we have that HBr molecule reacting with it, we form a mixture. We've got E and F. I get a mark for each, and it's asking us to draw the structures of those two organic compounds, and maybe you can probably foreshadow what the next question is going to be. So when we have that, we're just going to start off straight away just saying that these are the two products that we should have. Now in electrophilic addition for alkenes, they're going to go from an alkene, that double bond will no longer be there, it will then go to an alkane essentially. So go from a double bond between the two carbons to a single bond between those carbons. So we're going to break that bond because we are adding that H and that Br into this particular compound here. And we could either get E or F. Now if you write E and F, if you drew those the other way round, then that's not going to matter. But make sure you have the correct geometry. So we have the correct geometry for the alkene at the top, but then because we no longer have that double bond there, we're then going to have everything sort of straightened up, looking as they are there. So those are those two products there. Now, the next question, we're going to look at how we actually got to that point. So this is now these final parts of the question here. We need the mechanism. So starting with D, so obviously you can pause and go back to it if you need to see it. Compound D with the hydrogen bromide to form either compound E or F. Doesn't matter which one, because you might have written them the other way around than I did. It's absolutely fine. So for 3 marks, you've got to draw the mechanism for it with any relevant dipoles. So the first thing that we need in electrophilic addition of alkenes, we have our HBr molecule. Now we need to show the dipoles within that. So bromine is delta negative, hydrogen is delta positive. Now that electron-rich center is that carbon-carbon double bond. So the arrow, make sure the arrow starts at your double bond, and make sure the arrow is clearly pointing to the hydrogen. People lose marks if it's not clear where your arrows are starting and finishing. So make sure it starts at the double bond and it points clearly to that hydrogen. Now because of that, within the HBr molecule, the bond between the H and the Br is the electrons are going to go to the bromine. So that's why we've got that arrow in there. So those partial charges with those arrows to begin with. Now, depending on which one you're doing, depends on which intermediate you get. So we could have the one intermediate on the left or the one on the right hand side. So we're bonding that hydrogen to one of the carbons, so we no longer have that double bond there anymore. And we have a positive charge on the other carbon. So we have one or the other. Make sure you have that positive charge on that carbon. So that's the intermediate, needs to be there. Now don't forget that because those two electrons that were in that HBr bond, both have now gone to the bromine. So bromine got its 1 electron back that it donated, that it shared with the hydrogen, but it also took the hydrogen electron that the hydrogen was sharing. So now this bromine has an additional electron than what it normally has. So that's why we have that negative charge on the bromine. So make sure you've got that negative charge on the bromine and show that lone pair of electrons. Now, from those lone pair of electrons, make sure you draw a curly arrow pointing to that carbon. And again, make sure it's clear where your arrow is starting and where it's pointing to. And once you've done that, you will then form either your compound E or your compound F. So, from that, the final part of this question is asking us which E or F, depending on which one you've done, is the major product that you have. So, for myself, obviously, to know which one you did it, the 2-bromo 2-methyl pentane, or that particular structure there, is the major product. Now, the explanation as to why is down to the intermediate. The intermediate that we have in our mechanism on the right-hand side, that is a more stable intermediate because of those methyl groups on the carbon there. The more stable intermediate is the one we're going to form most of the time because we like stability. Stability is the key thing. So that carbocation is more stable. That's your answer, simple there. So you need both of those to get your mark there. Now, based on your question, if you might, from previous, obviously you can pause and go back. If you wrote a certain major compound for E, you could write E as your major compound, and then also maybe draw out. That would be fine as well. If I've had to write it and show you there because you might have it slightly different to what I have. So you could write E or F, provided you got that correct major product correct. You'd have that. Then you also, to get the 1 mark, you need the correct explanation in there as well. So you have that more stable intermediate. Okay, so that will do us for today on the electrophilic addition reactions in alkenes. See you next time.